Hello guys, Assalamu alaikum. I'm going to be answering question 1 from October-November 2025 Chemistry 9701 paper. Anyways, let's start. Chromium and its compound are widely used in many chemical reactions. Ignore this, doesn't matter. Chromium exists as 4 stable isotopes. The most common isotope is chromium 52. Determine the number of neutrons, electrons, and protons in an atom of chromium 52. Now, the easiest way to do this question is basically to look at the periodic table, which basically gives you the number of protons and electrons, as they're basically the same. The only thing you're supposed to find is the neutrons, which you can get by minusing this, and you end up with 28. After this, the next question is: describe how an atom of chromium 54 differs from an atom of chromium 52. Refer to the number of particles in your answer. Now, in the previous question, it basically said, or actually in the overall question, it said chromium exists as isotopes, right? Now, the difference in isotopes is basically the same, they have the same number of protons, they have the same number of electrons, but the only difference between isotopes is basically their nucleic mass, and this is due to a different number of neutrons, and this ends up giving them like a different chemical properties as well. So some of them have like different chemical properties, some of them have like other different chemical properties. They differ in chemical properties because of this. So therefore, you can just write that they have a different number of neutrons. Uh, Please don't write hashtag in your exam. Just write numbers. I'm just trying to save time. Anyways, the relative isotopic masses of isotopes can be determined using mass spectrometry. Suggest what other information is needed to calculate uh, relative atomic mass. Now, the formula for this is basically AR would be abundance of an isotope. Okay, actually, let me just go down. Yeah, like the relative atomic mass of like an isotope. Normally, you basically multiply the abundance by the isotopic mass. Like for example, one of them might have 98%. You multiply it by an isotope of 37, and then the other one might have 2%, and you multiply it by an isotope of 35, and then you have to divide it by the total abundance. Now the total abundance is basically, you can also write it as sum of abundance, and I think in AS level is basically always 100%. So basically, you always have to end up forming 100% of an isotope. So therefore, okay, so we have the relative isotopic masses of the isotopes of chromium. Now, what we don't have is basically the abundance. Therefore, using the formula and actually looking at the formula, we can already figure out that basically we just need the abundance, or the you can write, it's actually better to write abundance, relative abundance of each isotope, Yeah, that's better. Anyways, okay, let's move on to the next one. Atoms of 52 chromium, 53 chromium, and 54 make up more than 95% of naturally occurring chromium. The AR of naturally occurring chromium is 51.996. Suggest what these statements apply about the relative isotopic mass of the fourth stable isotope of chromium. Now, to understand this question is basic. Like all you have to do is basically compare. You just have to compare the isotopes with the average. So let's say these are the 4 isotopes that we have. This is the fourth one, right? The average is 51.996. Let's say if you take a number greater than 54 or greater than one of these numbers, for example, you have 54. Do you think the average is going to be below the numbers here, or no? Of course not. So let's take a number that is actually lower than one of these two. For example, 50 or 51. Will the average decrease or increase? Of course, it'll decrease, right? Therefore, it has to be you basically write there's a decrease. There's a decrease in isotopic mass. There's a decrease in isotopic mass. Or actually, let me just write decrease in relative isotopic mass. I apologize. Um, yeah, this is basically because like you just have to compare the average with the isotopes that they already gave you, and since they are basically greater than the average, you have to bring them down. You have to bring the average down somehow. Therefore, there has to be a fourth isotope that is actually smaller than the ones already given. Okay, anyways, moving on to the next question. The shorthand electronic configuration of chromium is AR 3D5 4S1. Complete the full electronic configuration of chromium. I mean, they already gave you the answer. You basically, if you memorize this, it becomes very simple, which is AS2, 2S2, 2P6, 3S2, 3P6. Now, we end here because they already gave us 3D5, which is basically the next orbital that you have to occupy. Anyways, the next question is deduce the number of deduce the total number of unpaired electrons in an atom of chromium. Unpaired electrons is basically when there's an orbital, but there's only one electron present. Now, let's say this is the 4s, and this is the 3D orbital, right? There's 1, 2, 3, 4, 5. Now, no, this doesn't happen. Since there's like 5 electrons, this is not going to happen because this is not stable. However, this is stable. So is this. This is also stable. This is also pretty stable because either they're going to have 5 or they're going to have 10. Otherwise, it's like unstable. So, so basically, either they have 5 unpaired along with 5 occupied orbitals, 5 occupied subshells. Basically, these are subshells. So, I mean, looking at this diagram, in my opinion, I think the best way to answer this question is basically drawing the diagram and filling up the orbitals. So here you have 1 unpaired. Here you have 1, 2, 3, 4, 5. 5 unpaired. Add them both. How much do you get? You get 6 unpaired electrons. Therefore, the answer is 6. It's simple as that, to be fair. Anyways, moving on to the next question. Acidified dichromate will convert methanol to carbon dioxide. Okay, interesting. The movement of electrons to or from relevant species is shown in the following half equations. Identify the species that is reduced in half equation 2. Let's look at half equation 2. You basically have dichromate ions here and you have chromium ions here. So I think the best thing that we probably should do is basically compare these two, because they're like the unique ones. In my opinion, when you see these type of questions, you always have to they always, like, normally they want you to compare the unique ones, or you could go for like an easy route, which is actually, now let me go with the harder route, which is, and the more safer route in here. Let's look at the oxidation state of chromium in the dichromate ion, right? It has -2. Oxygen always has a -2 charge, so you multiply that by 7, you end up with -14 and 2x, or let's just write 2 chromium to reduce confusion. You can take 14 to the other side, it becomes 12, 2Cr. Now divide 12 by 2, you get Cr is equals to +6, right? So this is basically the oxidation state of chromium. The oxidation state of chromium in the reactant side. Now in the product side, you can see that it decreases to 3. It actually decreases. It goes from 6 plus to 3 plus. Now what could have happened here? Basically, it gained 3 electrons. It basically got reduced. Reduction is basically the gain of electrons. Therefore, it has gained 3 electrons to actually end up with the oxidation state of +3 rather than an oxidation state of +6. So we can deduce that Cr2O7 2 minus is being reduced, or you can also write like Cr. You can legit just write the element because that's the only thing that's basically being reduced here. I mean, also let me mention the easy method. The easy method for this would be to just look at the oxygen. So, for example, here there's 7 oxygens, right? There's no oxygen here. Well, this one actually gains oxygen, so this one's being oxidized, while this one's being reduced. I mean, it doesn't work all the time because sometimes you might end up with two compounds that have oxygen, but here there's, I mean, it's pretty like distinct. You could easily tell. It's for 1 mark. I think even without doing the harder step, like without checking the oxidation states, I think you can easily answer this and get the free mark. Anyways, let's look at the next question. The oxidation states of carbon in methanol is 0. Okay. Calculate the oxidation states of carbon and carbon dioxide. I'll I'll answer this and then I'll show you why it's 0 here. Anyways, let's go. Let's draw. First of all, you should draw the compound, or at least um, basically write the formulae. So let's look at the formula. I think it's easier to do it with the formula. So we have 1 carbon, 2 oxygens, and it's a neutral compound. Therefore, it has an overall charge of 0. So 2 oxygens, it basically equals to 2 minus 2 equals to minus 4, right? So you have 1 carbon, uh, and then the overall charge is 0. Therefore, you can take the 4 to the other side, and you end up with plus 4. Therefore, carbon has a plus 4 charge in CO2. That's pretty good. Okay, and let's look at methanol, right? It's also a natural compound, therefore you have 0 charge at the beginning. You have 1 oxygen, you have 1 carbon, 2 hydrogens, and 1 oxygen, right? All of them equal to 0. Not all of them, sorry. Overall, it equals to 0. Oxygen is always going to have plus minus 2. Hydrogens always have plus 1 unless they're in a hydride, for example, lithium hydride or sodium tetraboral, whatever. I forgot the name. Anyways, plus 2. And carbon, we don't know it, right? Like, let's say we don't know it. Anyways, the 2 and 2 here would basically cancel, and C would basically equal to 0. Therefore, this is why they mention that in methanol, the oxidation state of carbon is 0. Okay, construct the ionic equation for the reaction of dichromate Vi ions with methanol in acidic conditions. Now, one thing you guys should notice, right? In acidified conditions, methanol does not form carbon dioxide. It actually forms methanoic acid. Methanoic acid. It does not form carbon dioxide straight away. It's basically supposed to form an acid. Any aldehyde or ketone, whenever you oxidize, actually not ketone, sorry, but any aldehyde, like especially definitely aldehyde, they definitely form. They always form a carboxylic acid. Like always. Whenever it's oxidized or whenever it's like slightly heated, or slightly acidified, it definitely forms carboxylic acid. So here, you go from methanol to methanoic acid, and then you can go to carbon dioxide if you oxidize this. Otherwise, you can't go straight away to carbon dioxide. So I think there's a mistake with the question, and also in the marking scheme, I'm pretty sure it says Na. So I don't think we have to do this. But basically, if you had to do this, I think it would be easy because all you have to do is basically you have to balance the electrons. Let's say we ignore the chemical mistake or the reaction mistake here that is mentioned. All you have to do is basically multiply them and make sure these two electron numbers match and cancel them. And then you basically combine the right side with the left side. And that's all you have to do to actually answer this question. Anyways, the next part is methanol is a liquid at minus 30 degrees, but carbon dioxide is a gas at this temperature. Explain why. Now, it's 2 marks, right? You can easily get 1 mark by just realizing that liquid has stronger IMF forces than gas. So you can legit write methanol has stronger IMFs. I mean, as a student, this was a cheat code, to be honest. You could just, I mean, you didn't have to look twice. You just had to You just have to realize it has stronger IMFs. Like solids, they might not have IMFs, right? But then liquid, they definitely do have IMFs. They definitely do have IMFs. So do gases. Like gases definitely have IMFs. So you can compare the IMFs, right? And liquid's obviously going to be stronger. So it's like a free, easy one mark. It's like a free one mark that you can possibly guess. Then sorry, not gas. Then carbon dioxide. Now the second point is two marked, right? So you have to mention 2 points. Another thing you can do here is basically you could notice the difference in structure or the difference in polarity to be exact. Let's draw the diagram, right? It's basically going to be this, this, this. Let's look at the polarity, right? Oxygen is obviously more electronegative than hydrogen or carbon, right? It's gonna pull electrons towards itself, right? Now let's look at carbon dioxide. The structure of carbon dioxide is basically this. There's two oxygens, right? Both of them are more electronegative than the central carbon, but both of them are basically going to be pulling towards opposite directions. Now, if you uh, look towards these signs, right, they're basically going to cancel each other. It's basically like doing 1 minus 1. It's basically going to equal 0. Therefore, there's basically going to be zero polarity. I mean, there's going to be zero dipole moment, which results in non-polar characteristic. So basically, carbon dioxide is non-polar. While here, there's actually a dipole moment because there's a difference in electronegativity, right? There's a difference in electronegativity. Obviously, the difference in electronegativity between H and C is basically not going to overcome the difference here. So significantly, this is far greater, right? This is going to be the overall difference in electronegativity in the entire molecule. While here, there's two of them, and they're basically the same. They're basically the same, so they cancel each other out, right? Therefore, this ends up becoming non-polar, and whenever you have like a difference in electronegativity, like a significant one, where it does not cancel out, you can consider you can consider the compound to be polar. Therefore, um, okay, moving on, you have to remember polar compounds. They have hydrogen bonding. They have permanent dipoles. Sorry, permanent, and they also have temporary induced dipole dipole forces. Dipole forces, right? They have all three. But then if you look at non-polar, right? The only thing they have is basically temporary induced dipole. They do not have this. They just have this. They're like, I mean, it's pretty straightforward, I think. It's pretty straightforward. Therefore, you can just mention that methanol, or you can mention. I think it's better to mention it from carbon dioxide's perspective, making carbon dioxide the subject of the answer, because you just have to mention one point, which is that carbon dioxide has weaker forces, has sorry, only has temporary dipole. Please do not write shortcuts, by the way. I'm writing shortcuts because I want to save time. I don't want to waste your time. Dipole induced forces. Apologize, I just woke up. Anyways, let me just refresh because I was solving this earlier. I just want to show it to you without the answers like straight away. Okay, let's move on to question number D, right? Question number D. I mean question D. Sorry. First question is basically what is meant by dynamic equilibrium. This is a definition that you have to memorize. Like you have to. It comes like I don't know 60% of the time. They love asking this question. Even me, when I used to be a student, I saw this question like in every 4 out of 10 past papers. So these are the points. Rate of forward reaction is basically equal to the rate of backward reaction. I mean, you have to write it in like proper sentences. You can't just write this bullshit. I apologize for swearing, but you can't just write this crap. Anyways, dynamic equilibrium would be the concentration of reactants would be equal to the concentration. Sorry, and concentration of products remain constant. I mean, if you memorize this and this comes in your exam, easiest free mark, bro. Easiest. Anyways, identify the condition necessary to establish dynamic equilibrium. Now, dynamic equilibrium is basically achieved by having a closed system. So basically, for example, there's evaporation occurring here. There's going to be condensation occurring here. This can only be possible if there's a closed system. If there's not a closed system, basically evaporation is going to happen, and خلاص, I mean, none of the gas is basically going to return. It's going to disperse. It's never going to return. Therefore, there's going to be no condensation, right? Therefore, a closed system is actually required for dynamic equilibrium to be reached. Okay, now this is a really fun question because I think it tests your understanding of equilibrium, right? It tests it. In my opinion, I think these were like really fun because it basically tests you. Anyways, let's read the question and let's see what they're asking for, right? Um, sorry, these ions. Okay, they gave us equation at the start. A dynamic equilibrium is basically established between, I forgot the name of this, but this is dichromate. Okay, this reacts with H plus ions and this forms dichromate and water. Okay, this is probably a key detail. I think we're gonna come back to this later. Just give me a second. Say what is observed when the following changes. Okay, that's the first pair of ions is basically yellow, and the second one is orange. Okay, say what is observed when the following changes are made to an equilibrium mixture of acidified first ions and then dichromate ions, right? Okay, these are acidified, these are not. Okay, let's go. The equilibrium mixture is warmed gently. As I said, we're gonna come back to this later, right? When this is greater than 0, it's an endothermic reaction, right? And endothermic reactions are favored when temperature is actually increased. So when temperature increases, the rate of the endothermic reaction actually increases. So both of them are basically directly proportional. So since this is already an endothermic reaction, it's basically the rate of forward reaction is basically going to increase. Therefore, here there's orange, right? There's yellow. If the rate of the forward reaction increases, the concentration of dichromate ions increases, right? Therefore, the mixture, I mean, you can write the mixture turns more orange uh, due to the explanation I just explained it due to the reaction being endothermic, right? The forward reaction being endothermic, right? Now the second point, okay, let's move on. Actually, to be fair, I think it's better to mention forward here. I think forward makes it way clear. Like it gives the examiner zero excuse to deduct any marks from you. Anyways, next, dilute HCl is added to the equilibrium mixture. Observation. Okay, dilute HCl is added to the equilibrium mixture. Observation and explanation. Okay, right. Let's look back at the equation. I think the best way to answer this question, I mean, these type of questions, is basically always going back to the main equation that they provide you with. What happens when you add HCl to anything, basically, regardless of whether it's dilute or concentrated? It deassociates into H plus ions, right? This increases the concentration of H plus ions in the reactants. Now, according to Le Chatelier's principle, any change that occurs in equilibrium is going to be reversed by the mixture. It has to be. That's his principle. It's going to do whatever it can to reverse it. Now, let's say you increase the concentration of one of the reactants. What's going to happen? The forward reaction is going to increase to compensate for the extra amount of reactants that are being added. So let's say, obviously, they already told us that they basically add dilute HCl, they add dilute H plus ions into the reaction. This provides more room and more this basically forces the equilibrium to shift to the right. It forces the equilibrium to shift to the right, produce more of the dichromate ions to compensate for the extra H plus ions produced, or H plus ions present. If I mean, this is pretty straightforward. I don't think I have to explain it further. But basically, all you have to do is basically uh, follow Le Chatelier's principle. So let's say we add more reactants, more products is basically going to be formed. Therefore, the mixture is basically going to be more orange, which is the same answer as the last one. It turns more orange. Turns more orange. This is because um, H plus ions are added and equilibrium shifts to the right. Basically, the equilibrium position is going to change to reverse the change in its conditions. It's basically like internal conditions. Whatever has been changed is basically going to reverse it by switching. H plus ions added, equilibrium shifts to the right to compensate for extra H plus ions. Yes, nice. Okay, question E. Chromium fluoride is a covalent molecule that shows similar chemical properties to silicon tetrachloride. Haha, I actually don't remember the name, but SiCl4. Okay, this already gives you a hint, I think, because I think when they mention these type of questions, they normally ask either properties or they're going to ask you reactions. I don't think they ask anything else. Anyways, suggest the type of reaction that occurs when chromium tetrafluoride is placed in water. Okay, since they said they show similar chemical properties to silicon tetrachloride, let's look at what happens when silicon tetrachloride faces off with water. Sorry. This would be the reaction, right? It would react with water. Anything that reacts with water normally is basically hydrolysis, especially, and I think this is one of the reactions that you have to memorize because this comes often too. They basically form silicon dioxide and it forms 4 HCl molecules, right? Now, since it has some similar chemical properties to chromium fluoride, it's basically going to be the same thing. The type of reaction is going to be hydrolysis. They're asking for the equation, right? CrF4 plus H2O equals 2. As similar to silicon dioxide, is basically going to form chromium dioxide plus chromium dioxide. Okay, since we have 2 oxygens here, while we only have 1 oxygen here, we basically multiply this by 2. We change the coefficient, and this becomes 4. And we also, by doing this, we also balance out the number of fluorine atoms that are present, so we can form 4HI. And yeah, that's about it. Thank you guys for watching, and let me know if you guys want to see any more questions being explained. Thank you. I'll be uploading something soon as well. Thank you. Assalamu alaikum.